Hello. Hey guys, what's good, y'all? Welcome to the stream. We are back at it solving lead code problems. So, yeah, I'm just gonna pick up from where we left off yesterday. Uh, there was this dynamic programming problem revolving around strings, whose approach we had figured out, just the implementation of which was pending. Uh, I'm actually debating whether it's worth it to implement the problem or do we just move on because I'm really confident or I'm sure of the approach because I had discussed this with ChatGPT and uh, even took some hints from ChatGPT to arrive at the problem. So I'm sure the answer will work. It's just, is it really worth it to implement? I think yes, let's do that. Let's do that quickly. Also forgot to set up my iPad stream, so might take a couple of minutes. Just give me a moment, guys. I'm just setting up my iPad stream. The way I make it work is I stream my iPad Notes app to Discord, and I log in through another user through my PC and watch that stream. And Discord has this neat little pop out mode so that the stream appears, without much of the Discord UI in the way. Cool, 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 cool. We have our stream. And yeah, this was the generalized uh, equation, you could say, for the DP problem we had arrived at with help from ChatGPT. I gotta find the problem once again. I don't remember the exact name. Yeah, I think it was distinct subsequences. Yep. We gotta have a 2D vector called memo to store all of our DP states. I just call it memo because this is memoization, right? Storing all the DP states, I think is what's called as memoization. I might be wrong. Let me cross-check this with ChatGPT. What is memoization in dynamic programming? Is it the act of storing states of or substates of dynamic programming solutions so as to make it more efficient and not having to recalculate every possible branch or possibility branch over and over again. Instead, we just store the result in one place and reuse it instead of having to traverse that possibility each time. Okay, I think I got it right with just a subtle nuance, which is it's not about storing every branch, it's about storing I guess, subproblems whose results are important to us. This has to be of length uh, s and t, the lengths of string s and t. T dot length. And I'm just gonna add one because I just feel it's handy to have an extra buffer because you're often looking on indexes. Or you know what? I think in this it's not gonna be useful because I'm looking at the previous uh, positions and not the ones which come after. So I'm gonna be looking at I minus one and j minus one and not I plus one or j plus one. So this is probably not needed. If j is greater than I, just quit. This is not a possible, or this is possible, but the answer is always 0. So just continue. If not, we gotta check and compare the last characters of the substrings uh, up to I and j respectively in strings s and t. If s of I equals t of j, then dp I j equals dp I minus 1 j plus dp I minus 1 j minus 1. If not, then dp I of j is equal to dp I minus 1 j. I could have simplified this and not have an explicit if else block by just using a ternary operator and made this whole thing just a simple single line expression, but I guess it's fine. It's more readable this way. Okay, what about when I and 0 or I or 0 are equal to, okay, wait, I meant to say I or j. So what happens when I or j are equal to 0? I guess in that case, this will just run into a runtime error. So I got to guard against that. I guess what I can do is go back, add 1, and make this whole thing 1 indexed instead of 0 based indexing. But I gotta make sure that when I query the strings, I query I minus 1 and j minus 1 because the strings are still 0 indexed. But I guess this is the only occurrence of me querying the strings. So I guess we should be good. I think we should be good, but there's still something wrong. Let's just consider the scenario where S is R and just the string R, by the way, and T is also just R. The answer is supposed to be 1 in this case, but I think my solution is going to return 0 uh, because the expression never has, I guess, a provision for when the indexes are at 0 and the strings are equal. I guess there has to be a special provision to kickstart this whole engine, because otherwise, even though the logic might be sound, it will never work because the initial values are always 0. So what do I gotta do? I think let's have dp of 0, 0 to be equal to dp of to be equal to 1. Let's do that. I think that should work. Okay, by the way, I'm calling it memo over here and dp over here, so that's a foolish mistake. Looks like even I'm not convinced with the naming system. Memo 0, 0 is equal to 1. What happens when S is AR? When I is 2 and j is 1, that state in our memo vector needs to be equal to 1. This condition is going to trigger memo 2 1 is going to be equal to memo 1 1 plus memo 1 0. Okay. What about memo 1 0? What about this? What about this? Memo 1 0. So memo 1 0 represents what? What does it represent? It represents when T is empty and S is some string, some character. And the answer here is, I guess, just 1 always, because if T is an empty string and you want to find a valid substring from S, which is equal to an empty string, then there is only one way to get that, which is to remove every character. So it means that not only is memo 0 0 going to be equal to 1, it means that all elements where the the second index is 0 is going to be 1. I guess that's what it tells us, and if we make that change, I guess this is going to start to work, at least the case that we took upon ourselves. For int j is equal to 0, j is less than m, or let's make it less than equals m, maybe, yeah, plus j, vector, oh wait, it's got to be I, right? It's got to be I, because j is fixed as 0. Memo I 0 is equal to 1. Will this work? Return memo n comma m. Will this work? It did. A runtime. Okay, it's a runtime error on 62 out of 66 test cases passed. So I guess I'm pretty close. What's wrong? What's wrong? Okay, it's an addition overflow. What does that even mean? How can it be an addition overflow? I ran into a similar problem a couple of problems back, a couple of questions back, or lead code problems back, I would say. Uh, but the solution there was to just ignore the possibility branch where the overflow occurred, because it just means that since the overall answer is never going to be greater than int max, even if an intermediate stage, it has a value which is greater than int max, we can just safely ignore it, because the constraints mention that the overall answer can never be larger than int max. But is something like that possible here? I don't think so. I don't think so. I think you need to depend on all the cells that came before you, and you cannot ignore a particular cell and just conclude that it is not going to contribute to the end state. I think that is a dangerous assumption, and I'm not comfortable making it. Okay, let's just try to uh, increase the bucket size. Define int long. I think this is the right way to make all of your ints become longs. Every int with long before compilation. Okay. Okay, then let's not do it, because I think you cannot change this. Control H. Return how do you safely cast a long back into an int? I know it's not a perfect operation, and many of the times it's gonna be, you know, just plain impossible, because there's more data, and you're trying to compress it into a smaller bucket, so it's not possible. But what is the best practice? I'm okay. So I'm like almost certain that um, the number which I'm trying to convert will fit into the int bucket. But if it's different, if the assumption fails at any point, then just store 0 in the int. I'm fine with that. Okay, I guess then let's try to fall back into fall back to the older solution, which is to just ignore the branches where there is an overflow, because I think that has to be the case even here. So if memo I minus 1 j is greater than int max minus memo I minus 1 j minus 1, will this work? I think it will, because even this test case passed, right? So let's go. Let's go. Hmm. Let's do a binary tree maximum path sum. Okay. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can appear in the sequence at most once. Note that the path does not need to pass through the root. The path sum of a path, the path sum of a path is the sum of the node's values in the path. Given the root of a binary tree, return the maximum path of any non-empty path. Okay, that's a lot to take in. A sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can appear in a sequence at most once. Okay. Note that the path does not need to pass through the root. Okay, so a path can be anything. There are very few constraints placed on the definition of a path in this question. So a path can be 1527, 1520 minus 10 9. It can be 20 minus 10 9. It can be 2015, or whatever. We are supposed to find the maximum path sum of any non-empty path. And there could be negative numbers, which is what makes this question interesting. Otherwise, it's going to be just the traversal of the entire tree. In this case, I guess the maximum path sum is going to be 1527, which is 42. Okay, let's bring up the iPad. We gotta have some traversal strategy, which starts from the leaves uh, and works its way up to the root. Because, okay, so this tree is binary. I guess that is mentioned in the problem. I guess it's mentioned in the problem topic. Uh, so when I'm at the root, when I'm at 10, let's assume that I'm 10, or negative 10 in this case, sorry. Uh, I just got to know what is the maximum sum path, which includes my two children. In this case, it's going to be 9 and it's going to be 42. And if I just got to decide two things actually. I got to decide what is the maximum path sum, which doesn't include me. It might be the global maximum, it might not, but what's important is that it doesn't include me. Uh, or you know what? Forget that. That is bad phrasing. What I got to decide is two things. One is the maximum path sum, which includes me, which is negative 10 in this case, and it's going to be 41. And second, I got to decide what is the maximum path sum, regardless of the fact whether it includes me or not. And that is going to be 42 in this case. So this is the responsibility of every node in the tree. That is what they have to find out about themselves. Now let's start with 7. For 7, the answer is simple. It has no children. So if it's positive, it's going to return its value in both the answers. So it's going to be 7, 7. But let's assume that it is negative, in which case it's going to return its value in the first space and just 0 in the second, because the best path, if it's a negative node, is to not include itself, to just return an empty path. The same uh, is going to be done by 15. 15 is going to do the same thing. 20 is going to look at 15 and 7 and decide, hey, they're positive numbers. I can include both of them. And even I'm a positive number, so I'm going to include myself in the path as well. So the answer is going to be 42, 42. And it's going to be 9, 9 here. And 10 is going to do what we just did initially and return 41, 42. And the main function, which is going to invoke this recursive solver function with the root, is going to look at these two answers and is going to return 42, and that's going to be our answer. So it's really simple actually. Yeah, it's really simple. I'm not gonna bother with writing the full C++ syntax code. I'm just gonna write some pseudocode and have ChatGPT formalize it for me. So uh, if left response, wait, what do I gotta do? I have the left response, I have the right response. Now I gotta find two things, which is uh, int first, okay, int max with me is equal to root val plus, okay, wait, max of root val max, wait, root. So the first case which I'm going to consider is just myself all alone. I'm not going to consider either of my children. The second the second possibility is root val plus just the left, root dot left, no, left response dot first. The third possibility is root dot val plus right response dot first, and the third possibility is all of the three combined plus. I guess I can make this a bit simple by having root dot val outside. Left response dot first plus right response dot first. This is gonna be max with me plus or it's gonna be left response dot second, right response dot second, I believe. And return max with me, max global get. Yeah, this should be good. I was trying to come up with a solution for a leetcode problem, and I know what the pseudocode is supposed to be. It's just that I'm not really familiar with C++ syntax. So I'm just going to give you a snippet of code which has pseudocode, and I need you to formalize it and make it in line with what C++ expects. Don't change anything, just rewrite the code in proper C++ format. But has a subtle issue. Okay, so it's not good to go. There is probably something which is left to be resolved, something which I've got to resolve. Okay, it works for the example cases. Wrong answer, -3. Okay, what happens if the entire tree is filled with negative values? I guess this is the edge case. Okay, I think I gotta return int min, and this should be good. The node val is -1000 to 1000, so I can just set this to uh, how do you tackle this? This is happening in line number 30. Okay, no, line number 21. The thing is, this is like uh, never gonna try, it's never gonna be forced into this variable. It's just an intermediate operation, which is used when we are trying to find out the max. So it's never gonna be stored. Uh, but still, I guess this is causing problems. Okay, I'm just gonna ask ChatGPT to fix this. Okay, I want to modify this piece of code. It works well, but instead of returning 0, 0 when we are in the condition where the root is a null pointer, I want to return int min. But this causes a problem because there is uh, an expression where we are adding the two values and trying to uh, find the maximum of all of the possible options. So there is an integer overflow because we're trying to add two int mins. Uh, can you solve this? Wait, why should first be 0? What does that mean? No, I don't think first should be. Or maybe it can. It can. What does first represent? Wait. Uh, I think I got tunnel visioned. What is the problem again with when the tree is just a single node with a negative number? Okay, the problem is that uh, this is not true. I mean, we don't have a globally good answer yet. Uh, Okay, so I guess it makes sense having intmin over there. Wrong answer. 2, -1, and -2. Okay. This is supposed to return -1 and -1, -2 and -2. And here you're supposed to compare max with me, which becomes 2 plus max of, wait, you're comparing? Okay, you gotta have 0 in the mix. Because there's also the possibility to not take anything, right? I hadn't considered that. Wrong answer again. Expected is 48, which is, I guess, the sum of all the nodes. Uh, so 16, 17, uh, 30, 35, 37. Oh, okay. Okay. Oh no, this is a big problem. This is a huge fucking problem. I'm getting 55 because that's the sum of the entire tree, but you cannot traverse all of the nodes and have it be a valid path. Okay, I think I got it. I cannot have both, I cannot include both the first and the, sorry, the left and the right children. I cannot include both of them and also include me and have it be a path which, um, okay, I mean, this is a bit confusing. The, the way you get 48 here is by excluding 4, 1, and 2. You subtract 7, which is the sum of 4, 1, and 2, from 55, and that is how you get 48, which which is what I'm doing wrong. I'm including these nodes, but it is not possible to have a path which traverses all the nodes of this tree. The best you can do is start at 13, go to 8, 5, 4, 11, and 7. That is the best path. You cannot go back to 2 without violating the condition that you cannot visit any node twice. Okay, I think I have the answer. So, max with me. This is what I'm giving to my parent, uh, and this is supposed to represent the maximum path, uh, including me, which I can give you, which you can connect to and append uh, 2. So 8 is going to give 5 uh, 21, which represents that, uh, imagine 8 telling 5, hey, whatever you've got, I can give you 21, like just free of cost. You can just add me, and it's going to be a valid path. Right? That's what, is being expressed by Max with me. Max global yet, I think, is not necessary. I think what we can do instead is, okay, so Max with me is right. I have a feeling that this is the, right solution, but the difference here is that I'm not including the possibility where I consider both the left and right children. Uh, so for 8, it's not going to consider the fact that a path is possible from 13 to 8 to 4 to 1. It's not going to consider that, but it should. It is possible that these are all negative numbers, in which case that path should have been considered. Uh, what I'm going to do then is max global get max global. Okay, I'll just bring back what I had. There is going to be another possibility here where it's root val plus left response dot second plus right response dot second. Here I'm contemplating whether including both of my children, or it should be first actually, not second, including both of my children and including me, which is the possibility where we have 13, 8, 4, and 1. Is this the max global answer? And I'm going to give that a chance. I think this should work. Let's go. Let's fucking go. Okay, a final medium problem to wrap up the day. Okay, what about this? Or maybe not. I don't want to do 2, 3 questions consecutively. Let's try to find something else. Populating next right pointers in each node. Longest consecutive sequence. Okay, let's try this. This seems like a standard problem. Given an unsorted array, so given an unsorted array of integer nums, return the length of the longest consecutive elements in sequence. Hmm. So hashing is not a possibility because the range of elements is way too high. Consecutive, okay. I guess you can create a hash map and it has order of one lookup, so you can solve it through that, but that is not what is expected. There is a clever solution to this. I'm thinking through the properties of consecutive numbers. What are the properties of consecutive numbers? There has to be some uh, quirky property which allows you to find this in order of n time. This consecutive this consecutive order, it can start from any number and end at any number. It just has to be consecutive. It is not a guarantee that it starts at 1 or 0. Um, in this case, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, which is how you get the answer 9. Okay, it says union find. Uh, okay, what that means is I'm gonna have n buckets at the beginning. Uh, let's bring up the iPad. I'm gonna have like n buckets, or maybe a better way of representing this would be, let's have like 5 buckets to begin with, and our array is nums, which is 100, 4, 200, 1, 3, and 2. 100, 4, 200, and what's left? 1, 3, and 2. I'm gonna add 100 to the first bucket, which makes its bounds be equal to 100 and 100. Right. And the bounds is basically the minimum element in that bucket followed by the maximum element. Then I'm going to go to 4. I'm going to see if any of the buckets I have um, is at a proximity of 1 unit to 4, which means is any bucket present whose minimum is 5 or whose maximum is 3. Right now, the answer to that is no, such a bucket doesn't exist. So I'll just create a new bucket for 4. And the bounds for this is going to be 4, 4. Next, I'm going to go to 200 and do the same thing once more. The same thing with 1. And now with 3, it gets interesting. I noticed that 3 is a perfect fit for the bucket 4. So in this bucket, we have 3 and 4. Next comes 2. and I'll add 2 to the bucket 1. Next, I'm gonna go over all of the buckets I've got and check if it's possible to connect any two buckets. And it is possible to do this. It is possible to connect the buckets with 3 and 4 with the buckets which have 1 and 2. So I get one big bucket with 4 numbers, which is my answer. And this seems difficult, but the disjointed set or disjointed set is the name of the algorithm, or sorry, the name of the data structure, and the name of the algorithm is union find, and this allows you to do such operations in a really efficient way. So I guess that's what you got to use to solve this problem. But is that the only way? Tell me more about the disjointed set data structure and the union find algorithm, and what kind of operations does this data structure allow for, and what are the time complexities of each of these operations. I'm trying to solve this problem. I think you can use the disjoint set data structure to solve this, but is that the only way? Hash set is a boring solution. Okay, but in an interview, I think using a hash set is not impressive, right? Because that is like the dumb solution, and it might not be the dumb solution. Maybe in in the real world, if I were to solve such a problem in a production system, then yes, I'll use a hash set. But I guess in an interview, uh, to flex your knowledge and come up with an interesting solution, the union set disjoint thing is probably going to be the more interesting and more appreciated answer. Am I right in saying this? Okay. I guess it's just me. I just hate hash set solutions. I feel like hash sets are like kind of this band-aid which gets overused in every problem. It might just be me. It just seems like the default answer. But that's cool. I mean, we learned about union find, and it's gonna come handy in some problem or the other. It's a really useful, really unique data structure. So yeah, I guess we're cool. We can just stop the stream here. There's no point in implementing the hash set problem because it's like super trivial. Um, so cool. I mean, thanks for joining. Thanks for watching. Have a great day. I'll catch you later, and we're gonna solve more LeetCode problems and eventually jump to competitive programming on Codeforces or any other relevant websites out there. So yeah, catch you later. Thanks for